We often think of the night sky as something still, calm, and eternal, a quiet dome sprinkled with distant lights. But this peaceful view is an illusion born from our small place inside a much larger structure. We live inside a galaxy, a vast rotating city of stars, stretching 100,000 light-years across, built from swirling gas clouds, cold streams of dark matter, and an intricate architecture sculpted by gravity over billions of years. The Milky Way is a disc-shaped orbiting system, home to hundreds of billions of suns, each following a path carved into the fabric of space-time by the mass around it. And yet, as enormous and ancient as our galaxy feels, it is not fixed. It is not anchored to anything. It drifts through the cosmos, pulled and pushed by invisible gravitational tides. Galaxies are not isolated islands. They move, collide, merge, and reshape one another in a cosmic dance that has unfolded since the dawn of time. Across the observable universe, collisions between galaxies are common, inevitable, and often spectacular, forming new spirals, smashing old ones apart, creating streams of orphan stars that arc through black space like celestial rivers. Even our own galaxy is part of this choreography. Though the night sky seems unchanged from one lifetime to the next, the Milky Way is already in motion, falling slowly toward our giant neighbor, the Andromeda Galaxy. Every moment we look up at the stars, we are watching the calm before an unimaginably grand event. So when we admire the quiet beauty of the sky, we are glimpsing only a temporary stage, a moment of stability in a story driven by gravity and time. Our peaceful view is just a pause in a much larger cosmic drama, one in which entire galaxies drift together, preparing for a future that will reshape the heavens themselves. Among all the galaxies scattered across the cosmos, none is more important to our future than the Andromeda Galaxy, the immense spiral that drifts toward us with quiet inevitability. Known as M31, Andromeda is a majestic system more massive and wider than the Milky Way. Its disk stretches over 220,000 light-years, nearly twice the diameter of our own, containing roughly 1 trillion stars, glowing blue giants, ancient red suns, and dense clusters orbiting in a graceful spiral structure. Its core is bright and compact, wrapped in thick lanes of dust and star-forming regions, forming a shape both familiar and alien, a mirror of the Milky Way, but on a grander scale. And yet, despite this enormity, Andromeda appears as nothing more than a pale, faint smudge in our night sky. The reason is simple: distance. At 2.5 million light-years away, its vastness is washed into subtlety by the sheer space between us. If our eyes were more sensitive, Andromeda would stretch across the sky wider than the full moon, a quiet reminder that we share the universe with giants. But size is only part of its story. Andromeda is not standing still. It is moving toward us at about 110 kilometers per second, a slow, almost imperceptible glide on human timescales, but swift and unstoppable on cosmic ones. For decades, astronomers knew it was approaching along our line of sight, but the missing piece was its sideways motion, its proper motion. Only recently, using the Hubble Space Telescope, scientists were able to measure this subtle drift across the sky, and the result was clear. Andromeda isn't just passing nearby, it is aimed directly at us. That tiny sideways shift, barely detectable, was the final confirmation of our shared destiny. The Milky Way and Andromeda are on a collision course, drawn together by gravity, weaving toward a future where the two great spirals will merge into one. The quiet galaxy we see as a faint blur today is the same one that will one day fill our sky with luminous arcs and brilliant tides of stars. The story of Andromeda's arrival does not begin with dramatic visuals or sudden movements in the sky. Instead, it begins with something subtle, a shift in the color of light. When astronomers point their instruments toward Andromeda, they see its spectral lines shifted slightly toward the blue end of the spectrum. This blue shift is the opposite of what we observe for most galaxies, which are drifting away due to the expansion of the universe. Andromeda is one of the rare exceptions. Its light is compressed as it moves toward us, a quiet but unmistakable signature of approach. For scientists, that change in wavelength is the first whisper of a cosmic encounter that will unfold over billions of years. But blue shift alone doesn't tell the full story. We also know that the distance separating our galaxies, currently about 2.5 million light-years, is slowly shrinking. It is not a rapid fall, it is more like a long, graceful drift. Each year, Andromeda comes closer by a tiny but measurable amount, adding up across cosmic time. On human scales, nothing seems to move. But in the language of galaxies, the motion is steady and certain. The void between us is closing. And something even more profound is happening beyond what we can see. Both the Milky Way and Andromeda are surrounded by enormous halos of dark matter, invisible, massive spheres that extend far beyond their visible stars. These halos overlap long before the disks of the galaxies come near each other. In fact, their dark matter envelopes are already interacting today, subtly altering the motion of stars at the edges of both systems. Long before the galaxies collide physically, they have already begun to touch gravitationally. The universe feels the connection before we can see it. This gravitational handshake is what makes the collision inevitable. Even if Andromeda had been moving slightly sideways, even if its orbit had been imperfect or skewed, the pull of dark matter would gradually draw the two systems together. There is no force in the cosmos capable of undoing this attraction. The combined mass of two giant galaxies ensures that their paths will curve inward until they meet. What begins as a gentle blue shift ends as a magnificent merger, a reshaping of both galaxies into something entirely new. So when we look at that faint smudge in the night sky, we are not seeing a distant object drifting alone. We are seeing a future partner already locked into our gravitational embrace, inching closer with every passing moment, preparing for one of the most beautiful and transformative events the Milky Way will ever experience. When we imagine galaxies colliding, it's easy to picture stars smashing into one another like cosmic wrecking balls. But in reality, the space between stars is so immense that even during a galactic collision, physical star-to-star impacts are almost impossible. Our entire solar system, the Sun, the planets, the moons, the long arc of the Kuiper Belt, is a tiny, fragile island drifting inside a vast ocean of space. Compared to the scale of two galaxies merging, we are smaller than a grain of sand caught in a slow-moving tide. And because stars are separated by such enormous distances, the chance that the Sun will collide directly with another star during the Milky Way Andromeda merger is so small it is essentially zero. The solar system will survive physically intact. But that doesn't mean the solar system will be untouched. What can happen, and almost certainly will, are changes to the gravitational environment around us. As Andromeda's stars sweep past, their collective pull can subtly reshape the outermost regions of our system. The Oort cloud, a distant spherical shell of icy bodies stretching nearly halfway to the next star, is particularly vulnerable. Even a slight tug from a passing star or from the evolving gravitational field of the merging galaxies could disturb some of these frozen objects. Millions of comets may be nudged onto new trajectories, and some could be sent plunging inward toward the Sun over millions of years. It's not a catastrophic danger, but a quiet cosmic rearrangement, a long-term increase in comet activity born from the shifting tides of intergalactic gravity. Closer to home, the planets will remain securely bound to the Sun. The Sun's gravity dominates their motion so completely that even the vast collision of two galaxies cannot tear them away easily. However, the solar system might drift to a new position inside the newly formed merged galaxy. Today, the Sun orbits the Milky Way about 27,000 light-years from the center. After the merger, we could find ourselves farther out in the halo, or deeper toward the luminous core. These changes unfold on timescales so long and subtle that life, if it still exists, will never notice them happening. And what about Earth? The planet itself will survive the encounter. Galactic collisions do not destroy planets. Gravity disperses, redirects, and rearranges, but it does not pulverize worlds orbiting stable stars. The true threats to Earth lie not in the merging of galaxies, but in the natural evolution of the Sun, which, billions of years before the final stages of the collision, will begin expanding into a red giant. The merger may decorate our sky with extraordinary structures, but it will not tear our planet apart. So even as two titanic spirals blend into one, the solar system remains a stubborn survivor, a small, warm pocket of stability carried along through the chaos, continuing its journey around the galaxy even as the galaxy itself transforms around it. If someone could stand on Earth a billion years from now and look up at the night sky, they would see a view so breathtaking, so impossible by today's standards, that it would feel like looking into the heart of a cosmic painting. By that time, the Andromeda Galaxy will have drawn much closer, enough that it no longer appears as a faint, ghostly smudge. Instead, it will stretch across the heavens, 2 to 3 times larger than it appears now. Its enormous spiral arms will no longer be hints of light. They will become great sweeping wings, luminous enough to be recognized instantly with the naked eye. The delicate structures that are invisible to us today will bloom into clarity. Dust lanes will form dramatic strokes across glowing arcs of stars. Star-forming regions will shine as pink and blue knots of light. The central bulge of Andromeda, that bright, dense sphere of old stars, will glow like a small, pale lantern in the sky, becoming the single brightest object after the moon. It will rise and set like a second galaxy-sized constellation, reshaping the meaning of night. As Andromeda continues to approach, the sky will grow even richer. The stars of the Milky Way will begin to mingle with the stars of Andromeda, creating a blended tapestry where the distinction between our galaxy and theirs starts to fade. Some of these distant suns will appear subtly displaced, scattered along new arcs formed by tidal forces. Others will shine in wide, soft streaks, the early signs of the two galaxies beginning to stretch and distort each other. This future sky will feel alive, shifting on a scale too slow for the human eye but clear enough over thousands of generations. What today looks like a quiet dome of scattered stars will become a dramatic panorama, painted with layers of light from two spirals slowly preparing to merge. The night will no longer be dark and empty. It will be a vibrant frontier, illuminated by the vast glow of another galaxy rising above the horizon. It is a reminder that the universe is not static. It breathes, moves, and changes, even in ways too grand for the present day to imagine. 2 billion years into the future, the quiet approach between the Milky Way and Andromeda will finally give way to the first true moment of contact. It will not feel like a crash. Galaxies are too airy, too spacious for anything abrupt. Instead, the collision will unfold like two giant clouds drifting into each other, their delicate structures compressing, twisting, and blending at the point where the disks begin to overlap. When the gas from both spirals meets, it will not remain calm. It will be squeezed, shocked, and forced into dense pockets where gravity suddenly becomes overwhelming. And wherever gas is pushed together, stars ignite. This will trigger a cosmic starburst, a period of furious star formation unlike anything our galaxy has experienced for billions of years. Entire nurseries of stars will flare into existence. Colossal clouds of hydrogen and helium will collapse under their own weight, giving birth to clusters so bright they will eclipse the famous Orion Nebula 1,000 times over. The night sky, once defined by quiet constellations, will swell with immense glowing arcs of new stars. These newborn suns will blaze blue and white, brilliant and short-lived, filling the heavens with a radiance never before seen from Earth. The collision will paint the sky with color. Gas clouds thrown into chaos will glow in vivid hues, pink from energized hydrogen, blue from hot young stars, violet from ionized gases swirling between them. As the two galaxies pull at each other, tidal forces will stretch long, luminous ribbons of stars across the sky, like cosmic brushstrokes connecting the spirals. Nebulae will become enormous, spanning regions so large they will be visible across half the sky, turning the night into an ever-shifting mosaic of glowing mist and starlight. These sights will evolve slowly, over millions of years, but at any given moment the sky will feel alive, dynamic, sculpted by gravity, exploding with new life. The collision will not be silent. It will be a visual symphony, a transformation in which two galaxies begin to weave themselves into one. And for anyone watching from a surviving planet, this will be the most spectacular era in the history of the night sky. The moment when the universe stops feeling distant and reveals just how violently beautiful it can be. By 4 billion years in the future, the Milky Way and Andromeda will be locked in a violent, elegant ballet, a gravitational dance so immense that it reshapes both galaxies with every pass. Their spiral disks will no longer merely brush against each other. They will penetrate and fold, slipping through one another like overlapping tides. Stars that once followed stable, predictable orbits around their galactic centers will be torn from their paths, flung into new trajectories by the combined pull of two titanic gravitational wells. Some will be sent arcing high above the galactic plane. Others will be hurled into deep intergalactic space, becoming lonely wanderers drifting between the merging giants. With each pass, gravitational tides will carve astonishing structures into the colliding galaxies. Gigantic tidal tails, ribbons of stars, gas, and dust, will stretch for hundreds of thousands of light years, pulled like glowing threads unraveling from a tapestry. These luminous trails will twist behind both galaxies, forming vast arcs that sweep across the darkness like cosmic brushstrokes. Immense bridges of gas and stars will form between the galactic cores, connecting them with shimmering pathways of gravity. Through these bridges, matter will flow from one galaxy to the other, feeding bursts of star formation and adding new layers to their tangled, evolving shapes. The night sky during this era will be unrecognizable, a chaotic masterpiece. The orderly band of the Milky Way will vanish, replaced by a sky dominated by distorted structures from both galaxies. One night, you might see a gigantic tidal tail cutting diagonally across the sky like a luminous comet stretching from horizon to horizon. Another night, a bright arc of Andromeda's shredded spiral arm may glow overhead in hues of blue and gold. Everywhere, nebulae twisted by gravitational turbulence will burn in shades of pink, magenta, and violet. The entire sky will look as if it has been pulled apart and painted anew with impossible colors. These changes unfold over millions of years, but from any single vantage point in time, the heavens will feel dramatic and alive, a cosmic storm captured in slow motion. The two once graceful spirals will no longer be separate galaxies but interwoven structures, their disks tangled, their stars scattered, their shapes stretched into wild forms. The chaos is not destruction, it is transformation. What we witness in this era is the middle act of one of the universe's greatest performances, the moment when two galaxies, caught in each other's gravity, dance toward becoming a single new world. Deep at the heart of every massive galaxy lies a monster, a supermassive black hole millions, sometimes billions, of times more massive than the Sun. The Milky Way has won. Andromeda has won. And when the two galaxies collide, these titans will begin their own, far more intimate and violent dance. At first, they will remain separated by tens of thousands of light years, drifting within the swirling chaos of the merging galaxies. But gravity is patient. Over hundreds of millions of years, the constant rain of gas, dust, and stars falling toward the centers will gradually drain away the black hole's orbital energy, pulling them closer together. Eventually, they will form a binary, two supermassive black holes orbiting each other in a slow, tightening spiral. Their motion will twist the very fabric of space-time, sending ripples outward, gravitational waves spreading like concentric rings in a dark cosmic pond. At first, these waves will be gentle, far too faint to disturb even the most delicate structures in the merging galaxies. But as the black holes draw closer, hundreds of light years, then just a few light years apart, the waves will grow in power. Each orbit tightens their embrace. Each passing millennium drains more energy into space-time. Their dance accelerates. In the final stages, the two black holes will circle each other at incredible speeds, whipping around in a frenzy of distorted light and warped time. The gravitational waves emitted during these moments will be so powerful that, if any civilization exists elsewhere in the universe with sensitive enough detectors, they will hear the collision as a deep, echoing cosmic chime, the sound of two galactic hearts beating as one for the last time. And then comes the climax. In a fraction of a second, the two black holes will merge. Space will shudder. A final surge of gravitational waves will burst outward like a silent cosmic explosion. And what remains afterward is a single, enormous black hole, far more massive than either of its parents, surrounded by a swirling disk of hot gas and newborn stars left shattered by the violent union. This new black hole will sit at the center of the merged galaxy, Milky Way, anchoring its structure for billions of years to come. This is the hidden drama behind the galactic collision, not just stars and gas blending together, but the ultimate convergence of two ancient gravitational giants. It is a moment of pure cosmic power, where the universe reshapes itself in an event so intense that even space-time cannot remain still. 7 billion years into the future, the long, turbulent dance between the Milky Way and Andromeda will finally come to an end. The graceful spiral arms that once defined each galaxy will be gone, torn apart by repeated collisions, stretched into filaments, and slowly dissolved into a new form. What emerges from this grand cosmic union is neither the Milky Way nor Andromeda, but an entirely new galaxy, a vast, rounded, golden structure astronomers call Milky Way. It is no longer a spiral, but an elliptical galaxy, a swollen, radiant cloud of stars shaped like a cosmic egg, smooth and immense, glowing softly against the dark. Where once the Milky Way shimmered with neat arms full of blue star-forming regions, Andromeda will appear as an enormous luminous sphere, its stars spread in a diffuse, blended halo. The violent starbursts that followed earlier phases of the collision have burned through most of the remaining gas. Nebulae, the pink glowing nurseries where stars are born, will be fewer and far between. With the gas exhausted, the galaxy enters a quieter era. New stars will still form, but far more slowly, emerging from the remnants of disrupted systems rather than from great clouds of pristine gas. The sky becomes smoother, softer, filled with older stellar populations that radiate warm hues of amber and gold. For any surviving world within this galaxy, the night sky will look profoundly different. Instead of the thin shimmering band of the Milky Way stretching overhead, the heavens will glow with a broad, diffuse radiance. Countless stars will fill the sky in every direction, not as sharp points but as a soft golden haze, like the glow of a distant cosmic sunrise that never sets. The signature spiral structure is gone, replaced by a quiet sea of ancient light. Amid this transformation, the solar system continues its long journey. The merger's gravitational upheavals may sling the sun far from the place it once occupied. Today, our star lies about 27,000 light-years from the center of the Milky Way, but inside Andromeda, it may find itself cast much farther out, drifting in the wide halo that surrounds the new galaxy. The sun and its planets will still orbit, but their path will be reshaped by the gigantic gravity of the newly merged core. From that distant vantage point, the center of Andromeda will shine as a bright, golden heart, a glowing reminder of the two galaxies that were once separate and are now inseparable. This new galaxy marks the final stage of a story billions of years in the making. What began as two swirling spirals has become a calm, rounded giant. The fireworks of collision are over. The chaos has faded. What remains is a serene, ancient structure, a monument to the power of gravity and time. Andromeda is not just the future of the Milky Way. It is a new chapter in the cosmic story, written from the debris of two once mighty galaxies that merged to form something larger, quieter, and endlessly beautiful. When people hear the phrase galactic collision, it's easy to imagine catastrophic destruction, stars smashing into each other, planets vaporizing, entire systems torn apart. But the reality is far more gentle. Space inside galaxies is astonishingly empty. Even when two galaxies pass directly through one another, the chance that two stars physically collide is almost zero. The sun will drift through the chaos untouched, and planets that orbit tightly around their stars, like Earth, are not in danger of direct impact. Galaxies collide, but stars almost never do. That said, there are more subtle effects. As the Milky Way and Andromeda merge, the gravitational landscape around the solar system will change. Stars passing at great distances can tug on the outermost regions of our system, especially the Oort cloud, which contains trillions of icy bodies loosely bound by the sun's gravity. Some of these objects may be nudged onto new orbits, sending comets into the inner solar system more frequently. On very long timescales, the sun's position within the merged galaxy may shift as well, altering our environment without posing immediate danger. Radiation from regions of intense star formation could increase, but only for systems closer to the galactic core. Worlds far from the center, including where the solar system is likely to end up, will experience only a mild rise in background radiation, not enough to threaten life. The most dramatic events, such as the merger of the two supermassive black holes, release energy primarily as gravitational waves, which pass through matter harmlessly. Ultimately, the greatest risks to humanity come not from colliding galaxies, but from far more familiar cosmic cycles. Long before the final phase of the merger, the sun will have begun evolving toward its red giant stage, transforming Earth's climate beyond recognition. By the time the galaxies fully combine, humanity will either have evolved, migrated, or vanished. From a cosmic perspective, life will not be harmed by the galaxy's transformation. The collision is spectacular but not lethal, a grand celestial show that unfolds too slowly and too gently to threaten civilizations directly. In the grand scheme, the merging of galaxies is not a danger but a reminder. Life exists in a universe that changes on timescales far larger than any species. The cosmos evolves, and life adapts, or disappears, long before the stars themselves collide. Our confidence in the future collision between the Milky Way and Andromeda doesn't come from guesswork. It comes from a combination of cutting-edge simulations, precise observations, and the fundamental laws of gravity. One of the most powerful tools we have is the family of computer simulations that model the evolution of galaxies across billions of years. Projects like Illustris, Fire, and NASA's detailed collision models take the physics of stars, gas, dark matter, and gravity and evolve them forward in time. These simulations consistently show that when two massive galaxies approach each other with the speeds and masses that we observe, the outcome is always the same. They merge. The details change from run to run, but the broad conclusion is universal. We also confirm this by observing galaxies throughout the universe that are already colliding. Astronomers have identified countless examples that mirror the stages the Milky Way and Andromeda will undergo. The antennae galaxies, with their long sweeping tidal tails, show what happens when two spirals begin tearing each other apart. The mouse galaxies, with their elongated stellar streams, capture the moment when one galaxy stretches the other like cosmic taffy. And the whale galaxy, bent and distorted, reveals the violence of gravitational tides during close encounters. These systems are snapshots of our own future, real, observable evidence that galactic collisions are common and follow predictable patterns. Finally, gravity itself is a remarkably reliable guide. The laws that govern the motion of planets, comets, and spacecraft in our solar system are the same laws that govern the motion of galaxies. When we apply these laws to the measured mass, velocity, and dark matter halos of the Milky Way and Andromeda, the result is straightforward. Their mutual gravitational pull is too strong to allow them to drift apart. They are falling toward each other, slowly but surely, in a trajectory that will only end in a merger. This is physics at its cleanest and most precise, a cosmic inevitability written into the structure of space-time. Together, simulations, observations, and fundamental laws all point in the same direction. We are watching the early chapters of a story whose ending we already know. The future merger of our galaxy is not a possibility. It is a certainty, a predictable thread woven into the fabric of the universe. Across the vastness of time, galaxies follow a rhythm older than stars themselves. They are born from collapsing clouds of gas. They spin and shine. They collide and reshape one another. And in the end, they fade into quieter forms. Every galaxy carries a history written in its structure, scars from past encounters, streams of stolen stars, cores built from ancient mergers. The Milky Way, as grand as it is not eternal. It is simply one chapter in the endless evolution of the universe, a temporary expression of gravity and light. When we look at the night sky today, we are not seeing the present. We are witnessing ancient light, millions of years old, arriving from stars that may have already changed or disappeared. The constellations that feel so permanent are momentary patterns, frozen only because our lives are too short to witness their motion. The universe moves slowly, but it never stops. And the story of our galaxy is still unfolding. Before us lies a future woven from both beauty and transformation, the great dance of the Milky Way and Andromeda. Two enormous star cities drifting together across billions of years, preparing for a collision that will erase their familiar shapes and give birth to something entirely new. This event is not destruction but creation, a reshaping of cosmic architecture, the forging of new stars, and the emergence of a new galaxy that will shine for trillions of years after the spirals we know have vanished. In the end, the story we belong to is far larger than our planet or our time. We stand on a small world orbiting an ordinary star, yet we are witnesses to the universe rewriting itself. And so the final thought remains. When we look at the night sky today, we are seeing the past. But ahead lies the grand dance of two universes, a union that will carve a new home from the stars of old. This is the cycle of the cosmos, creation through transformation, beauty born from collision, and the eternal motion of galaxies across an ever-expanding universe.